So let's talk about section 4-3, the periodic table. Now Mendeleev is a guy who gets credit for coming up with the first periodic table. It wasn't perfect, and it's a little different than the current modern day model, but he was onto something, and he gets credit for it. We'll talk about why in the next little question here. So this question says, how did he first arrange his periodic table? Well, he arranged the elements according to their mass and according to their properties or behaviors. So he noticed that certain elements did certain things and they were very similar, so he put them in the same area of the periodic table, and then he looked at their atomic mass and tried to arrange them so they increased in atomic mass. Now the current periodic table is arranged very closely to the way Mendeleev did. However, it's not based on atomic mass, it's based on atomic number of protons. When Mendeleev was arranging the periodic table, they didn't know about protons, neutrons, electrons. They didn't know about atomic number at the time. They just knew how heavy atoms were. So he arranged everything based on mass, and then it got rearranged a little bit based on atomic number. Now the cool and properties and behaviors, don't forget that. Now the cool thing about what Mendeleev did was that not only did he organize the elements in a way that people could kind of group them and understand the properties and behaviors of things, but he was able to use it to predict the properties of undiscovered elements. So there were some elements that nobody had discovered yet, and he knew what the properties were going to be because he knew what this element was and what this element was. And he took the properties of this element and averaged them together, and he found out what the properties are going to be for the element in between. And he also looked at the properties above and below it, and he averaged them, and he knew even more properties about this element without even knowing what the element was. Nobody had even found it at the time, but yet he was able to describe the elements. So he left a few blank places, and he also knew what the properties of those elements were going to be. And when they were discovered and the blank places were filled in, sure enough, they had the properties of above it and below it, or left and right, the average of those properties. All right, so today's periodic table. You should remember that metals are on the left, non-metals are on the right of that zigzag line or that stair step. These are the metals, these are the non-metals. And we'll jump down here for a second. The metalloids are found along the line. Metalloids, they're found along that zigzag line. One exception here, aluminum. Here's boron, and there's aluminum. And aluminum is right along the zigzag line. Aluminum is not a metalloid. Aluminum is a metal. So make a little note to yourself. Aluminum is a metal, not a metalloid, even though it touches. But all the rest of them that touch are metalloids, or semi-metals, we call them. And semi-metals share properties of metals and non-metals. So let's look at the properties of metals. They're shiny, they have luster. They're ductile, which means we can draw them into thin wires. They're malleable, meaning we can shape or mold or hit them. Good conductors of heat and electricity. This is because of that sea of electrons. The electrons are kind of free to flow around and move. So when we take electricity, which is basically electrons, and we force electricity, more electrons, through a sample, it's going to push the electrons that are already in the sample. It's going to push them through. So if here's my metal, and here comes all these other electrons, these electrons can bump those electrons, and together they could all, these guys will bump into those, and they'll all just kind of push along, and that's what electricity is. Electricity is a flow of electrons. And they react with acid to produce hydrogen bubbles. Now you knew this because you ran a lab where you put magnesium into hydrochloric acid. And remember, the magnesium took that little hydrogen and bumped them out. So the magnesium got to hook up with the chlorine and make magnesium chloride. Then where'd the little hydrogen go? Well, little hydrogen was upset because it was with the chlorine, but then it got bounced out. So one little hydrogen looked at another little hydrogen and said, we're not happy anymore all by ourselves, so let's pair up together and let's make H2. And we saw gas bubbles of hydrogen. So metals react with acids to produce hydrogen bubbles. Now nonmetals do the opposite. Nonmetals don't have that sea of electrons, so they are dull. They don't have the electrons there floating around that are allowing it to be ductile or malleable. Instead, it's brittle. If you hit it, the electrons aren't going to, if you hammer a metal, the electrons will kind of move around. If you hammer a nonmetal, it's brittle, if it's even a solid. A lot of them are gases. But if you hit a nonmetal, it's just going to shatter. It's going to break into a billion pieces here. They're not really good conductors of heat and electricity, and they don't react with acid. You drop a nonmetal in, and it just kind of sits there. All right, the next section is basically just memorization. Group 1 are what we call the alkali metals. We know they're metals because they're on the left of the zigzag, but just think there's alkali and alkaline earth. This has got one word and then the word metal. This has got two words, and then the word metal. So you could just think alkali versus alkaline earth metals. Then we just name the groups based on the top element in each group. So boron group's got boron up there. Carbon group's starts with carbon at the top. Nitrogen group starts with nitrogen, and so forth. The seventh group are called the halogens. This is where fluorine is. Fluorine, chlorine, bromine, iodine. These guys end with S2P5. They all have 7 valence electrons, and they need one more. So they're going to end up gaining 1 to get the 8. The noble gases have 8. They end in S2P6 except for helium. Helium ends in S2. And helium's nice and happy with its 2 valence electrons. Everybody else wants to get 8. So if you have 1, you're going to kick out your 1, kick out your 2, or kick out your 3. If you have 4, you're going to share. And if you have 5, you're going to gain 3. If you have 6, you're going to gain 2 electrons. And if you have 7, you're going to gain 1 electron. So all of this hopefully should start connecting for you. Now, elements in the same group, if they're in the same column, that's a group, they're in there because they share similar properties. Now, why do they share similar properties? Because they have similar electron configurations. So every element in group 1 is going to end in S1. 1s1, 2s1, 3s1, all the way down. And because they all have 1 valence electron that they want to get rid of, they're all going to react the same way. Similarly, I don't know, maybe the halogens, we'll talk about those. This is group 7. Group 7 elements, they all have 7 valence electrons. They all end in S2P5. So they all want to gain 1. And that determines how they behave. And which group is most unreactive? These are your noble gases. Noble gases already have stable noble configurations. They end in S2P6. They have their 8 valence electrons, except for helium. Helium's got 2 valence electrons. But all the rest have 8, and they're nice and happy. They don't need to do anything. They don't need to gain, lose, or share electrons. All right, trends, quickly. We go across a period or down a group. When you're comparing 2 elements and you're going across a period. So for comparing this one and this one, I'm just randomly picking one. But these 2 are across the same period, the same row. We're not going up or down at all. We're just going across. What we're concerned with is the fact that there's more protons in the nucleus over here. These guys have more protons. And because they have more protons in this side, they pull the electrons in tighter. Remember, protons are attracted to the negative electrons, so they pull them in. So there's a stronger pull, pulling it in tightly, and makes the right side smaller. Smaller on the right. And it obviously would be bigger on the left because it's not pulling it in as much. Now, what if you were asked to compare 2 elements going down a group? What if I said compare this guy and that guy? What happens as you go down? Well, the size gets bigger. Don't overthink this. This is pretty simple. It gets bigger. Why? Because we have more energy levels. The atoms near the bottom have more energy levels, so they're larger than the ones near the top. This is very basic. Don't overthink the down. This one is a little tricky. As you go across, most kids think it gets bigger because you got more protons. But in fact, if you have more protons, stronger pull makes it smaller. Oh, and finally, let's talk about ions here. What happens to the size of the following atoms when they become ions? If we're talking about a cation, we're talking about something that is going to become positive. How does it get positive? It loses electrons. All your metals, they have that T in the middle too. The metals are going to give up electrons, they're going to lose electrons, and the atom is going to be big, the ion is going to get smaller. So cations lose electrons. So if we have a lithium atom, here's our atom, it gives away 1 electron. And when it gives away an electron, it's now smaller. So the ion is smaller. Here's sodium giving away an electron. Now it becomes smaller. Here's magnesium. Magnesium gives away 2 electrons, and it becomes a really small ion. Here's aluminum atom. Aluminum gives away 3 electrons. There goes 3 electrons, and now it becomes an ion. And the ion's really small because it lost 3 electrons. So these in green, the ones that I circled or squared in green, these are all your cations. These are your metals. These guys all lose electrons, so the ion gets smaller. The right side, let's use blue here, the right side are all of your nonmetals. Well, how do the nonmetals get to be ions? They become negative. And how do you get negative? You gain electrons. So all of these guys are going to gain. The atom, here's a little nitrogen atom, and it's got 5 valence electrons. Here's nitrogen, 5 valence electrons. It needs 3 more. So nitrogen is looking out to get 3 more electrons to stick in that electron cloud. All these guys are negative. They repel each other, so it puffs out. The nitrogen ion gets bigger. Here's oxygen, or sulfur, or selenium. All of these guys are atoms that are unhappy because they all have 6 valence electrons. They gain 2. And when they gain 2, they end up with 8. So all the ions, after they gain their 2, are bigger. And these guys, the atom has 7 valence electrons. It wants 1 more, so it gains 1 to become 8, and then it makes a bigger ion. So if you gain, you get bigger because the electrons repel each other and they spread out. If you lose, the electrons are going to be wiping out usually a whole energy level, and the ion is now smaller than the original atom because it has less electrons.